Hello students. Today's first question is, in the morning batch at Lamamia, we have observed that when 5 students took seat on a bench, 4 students remain unseated. But when 11 students took seat per bench, 4 benches remain vacant. The number of students in our morning batch were. So let us suppose K be the number of benches, right? Now, when K is number of benches, the first statement says, when 5 students took seat on a bench, 4 students remains unseated. So that means 5 into number of benches plus 4 students remain unseated. But when 11 students took seat per bench, 4 benches is so 11 multiplied by K minus 4 because 4 benches remain vacant. Now we'll solve this. 5K plus 4 is equal to 11K minus 44. Now shifting this to this side, 11K minus 5K is 6K. 44 to this side, so this will become 48. So this implies K is equal to 48 by 6. Right? So this means that K is equal to 48 divided by 6 is 8. 8, 6, 48. So number of benches are 8. Now number of students will be 5 multiplied by 8. So number of students will be 44. Or you can solve from here also. 8 minus 4 is 4. 11 into 4 is 44. So right option, since options are 55, 48, 26 and none of these. So right option is option D, none of these. The remainder obtained when 1 factorial plus 2 factorial plus 3 factorial so on up to 77 factorial is divided by 7 is. So we have been given 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial so on up to 77 factorial, and we need to find the remainder, and this whole expression is divided by 7. Now 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial is 6, 4 factorial is 4 into 3 into 2 equal to 40, 12 to 24. 5 factorial is equal to 5 into 4 factorial. So this will be 5 into 24, which is equal to 120. And 6 factorial is equal to 6 into 5 factorial. So this will be equal to 6 into 120 equal to 720. Now, beyond this will be 7 factorial, 8 factorial. So every factorial beyond 6 factorial will contain 1 7, at least 1 7. So that means every factorial beyond this will be divisible by 7. So we'll need to add this one. So this is 840, 864, 870, 872 and 873. So we need to find 873 divided by 7. So this gives 1 remainder 14, 2, 33, 4, 28. So remainder is 5. So for this whole expression the remainder will be 5 and right option will be B, because beyond 6 factorial every factorial will contain at least 1 7 and will be completely divisible by 7. So we add up to 6 factorial and we get the remainder as 5. So right option is option B. If AB plus 4 is equal to CD, now we have been given AB plus 4 is equal to CD and BA plus 40 is equal to DC. BA plus 40 is equal to DC, where AB, CD, BA and DC are 2-digit prime numbers. Further, B and D are prime number digits. So B and D are prime numbers digits, right? And A and C are neither prime nor composite. The value of AB plus BA upon CD plus DC is, so A and C are neither prime nor composite. That means A should be equal to C should be equal to 1, right? Because the number which is neither prime nor composite is only 1. Now we have been given that AB, CD, BA and DC are 2-digit prime numbers. So we need to satisfy these two equations. Now what values BD and can take? So B, because these are prime numbers, so B can take this value and D can take these digits only, 2, 3, 5, 7. Now AB plus 4 is equal to CD. So if I put first value 2-digit prime number, if I put it AB equal to 13 plus 4 is equal to 17. Right? Now 13 plus 4 is equal to 17. Now this is a prime number. This is also a prime number, satisfying the condition. Now we'll check for BA plus 40. Now reversing the digits, I get 31 plus 40, and I should reverse this digit, so this will be 71. Now 31 plus 40 is equal to 71. So this satisfies the condition. Now this is AB, this is CD, this is BA, and this is DC. So AB plus BA whole divided by CD plus DC. So AB is equal to 13 plus BA is 31 divided by CD is 17 plus 71. So this becomes 44 divided by 88. So this is basically 1 by 2. So the value is, right option is option number B. A man sells chocolates which are in the boxes. Only either full box or half a box of chocolates can be purchased from him. A customer comes and buys half the number of boxes which the seller had plus half a box more. A second customer comes and purchases half the remaining number of boxes plus half a box. After this, the seller is left with no chocolate boxes. How many chocolate boxes did the seller has initially? So let us suppose the seller had initially X number of, let X be number of chocolate boxes initially, right? Now according to the condition, a customer comes and buys half the number of boxes. So that means he buys 1 by 2 of X plus half a box more. So that means 1 by 2 of 1. So that will be 1 by 2. So taking 2 LCM, I would be left with, so basically he buys X plus 1 by 2. Now a second customer comes and purchases half the remaining number of boxes plus half a box. So that means half of remaining. So remaining will be, first we'll find remaining will be X minus X plus 1 by 2. So this will be equal to 2X minus X minus 1. So this will be equal to X minus 1 by 2. So these are the remaining number of boxes. So he buys half of the remaining number of boxes. So half of this, half of X minus 1 by 2 plus 1 by 2 more. Because it says plus half a box. So half a box means 1 by 2 of 1. After this, the seller is left with no chocolate boxes. So no chocolate, that means initially were this one. So this plus X plus 1 by 2 should be equal to X. Now taking LCM, so this implies this is equal to X minus 1 by 4 plus 1 by 2 plus X plus 1 by 2 equal to X. So this further implies, taking 4 LCM, so this will be X minus 1 plus 2 plus 2X plus 2 equal to X. This further implies 2X plus X 3X plus 4 minus 1 3 divided by 4 is equal to X. Now this implies 3X plus 3 is equal to 4X. So this implies if I shift this to this side, so I get X is equal to 3. So number of boxes initially were 3. Fine. Now if you want, we will check it also. Now first customer comes and he gets half of this. So that will be 3 by 2 plus 1 by 2. Fine. So what is that? This is equal to 2, 4, 2. So this is 2. Now the second customer comes, he gets half of the remaining. So 3 by 2 has been gone. So what would be left out of 3? 3 by 2. So half of that will be 3 by 2, and that's half. So remaining boxes out of this will be 3 minus 2 equal to 1. So half of that will be 1 by 2 plus 1 by 2. So this is equal to 1. So total 2 plus 1 equal to 3. So the right option is option number B. If A minus 7 multiplied by B minus 10 multiplied by C minus 12 is equal to 1000, the least value of A plus B plus C equals. So we need to find the least value of A plus B plus C. Least value, right? Now since this product is equal to 1000, least value can be possible only when A minus 7 is equal to B minus 10 is equal to C minus 12. Now in what scenarios it can be equal? It can be equal and this product should be equal to 1000. So if I take A minus 7 equal to 10, if all these values are equal to 10, so A will be equal to 17 B will be equal to 20, and C will be equal to 22. And all these values will be equal to 10, and this will be equal to 1000. So A plus B plus C, the least value will be equal to 17 plus 20 plus 22, which adds up to 59. So this is the least value of A plus B plus C. So right option is option number A, 59. A 6-digit number is such that every alternate digit is a prime digit. So every alternate, and the 3 leftmost digits form a GP, while last 3 digits form an AP. If it is expressed as PQ, R, S, T, U, where P plus, now it has been given that P plus Q plus R is equal to U. So that means first 3 digits should be equal to the digit at units place. Q plus R is equal to T. P plus R is equal to S, and R by T is equal to 2 by 3, and P is not equal to Q, is not equal to R, is not equal to S, is not equal to T, is not equal to U, right? So these have been conditions. Then the sum of all the digits must be. Now we know that P, Q, R, every alternate is a digit, is a prime digit, right? Now, and these 3 digits, first 3 leftmost digits form a GP. So these form a GP, while last 3 digits, that means hundreds, tens and unit, these form an AP, right? Now R by T is equal to 2 by 3, right? So what does that mean? That means R by T ratio is 2 by 3. Now if the possible digits I can have are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. Now which digits form a GP? First we will calculate those. So if I take 1, 2 and 4, 4 divided by 2 is 2, 2 divided by 1 is 2. So I can first assume PQR to be 1, 2, 4. So I can write 1, 2, 4 for this. Now P plus R is equal to S. This has been given over here. So that means P plus R is equal to S. So P is, this is P, Q, R. So S should be equal to 5, right? Now PQR is equal to U, P plus Q plus R. So this is 7. So leaving one space, so here I can write 7. And Q plus R is equal to T. So Q plus R is, this is 6. Now we'll check for other criterias. Now last 3 digits form an AP. So 7 minus 6 is 1, 6 minus 5 is 1. So these are consecutive digits, so this form a AP. Now all these conditions have been satisfied. We need to check for R by T. So R is this and T is this. So basically 4 by 6. So this is 2 by 3. So this condition is also satisfied. And all are different digits. GP and AP conditions are also fulfilled, and these are not same digits. So now we need to find the sum of all digits. So that will be, number will be 1, 2, 4, 5, 6, 7. So sum of digits 7, 6, 13, 15, 13, 5, 18, 22, 24 and 25. So sum of digits is 25. So right option is option number A. If A and B are divided by D, then the remainder obtained are 13 and 31 respectively, where A, B, D are natural numbers. Further, A plus B is divided by the same divisor D, the remainder is 4. Then the divisor D is. So we have been given, then when A is divided by D, remainder is 13. And when B is divided by D, remainder is 31. Right? And further, when A plus B is divided by D, the remainder should come 13 plus 31 is 44. Right? But here it is given that the remainder is 4. Actually remainder is coming 4. So divisor will be 44 minus 40. 44 minus 4 equal to 40. So the right option is option C. If PQR are such that PQR, P, Q, R are such that Q minus P is equal to R minus Q is equal to 2. No, Q minus P is this difference and this difference R minus Q. Now these differences are equal to 2. So this means PQR are in AP. Now where PQR belongs to positive integers, then the least possible value of P plus Q into Q plus R into R plus P is. Now for this to be least, this AP should be least. So if I suppose P should be equal to 1, in that case Q will be equal to 3, because Q minus P should be equal to 2, and R will be equal to 5, because R minus Q should be equal to 2, because this difference should form an AP. The difference should be equal. It is 2 and 2. Now P plus Q is 4 multiplied by Q plus R, which is 3 plus 5, 8, R plus P, 5 plus 1, 6. So this is 32 into 6, which is equal to 30 into 6 is 30 plus 2 into 6. So this is equal to 180 plus 12, 192. So the least value of this expression is 192 value, option number A. From IIT Roorkee to IIM Kashipur in Uttarakhand, there are 325 railway stations falling on a straight railway line. A local train stops at every third station. So local train stops at every third station. Now an express train stops at every fifth station. Express train stops at every fifth station. And a bullet train stops at every 8th railway station. So bullet train stops at 8th station, right? How many pairs of stations are connected by exactly 2 different types of trains? So in between 2 stations there are total 325 railway stations. We need to find the stops where exactly 2 trains out of these 3 trains stop. Exactly 2 trains stop, right? Now first of all, a local train and an express train. So we'll talk about local train and express train, right? Now it stops at every 3rd station and express train stops at every 5th station. So both will together stop at every 15th station, right? Just by taking the LCM, and both are prime numbers. Now out of 325 stations, these 2 trains will stop at 325 divided by 15. So this is equal to 21 stations, right? Now local train and bullet train. Now the combination between local train and bullet train. Local train and bullet train. Now this stops at every 3rd station. This stops at every 8th station. So this is both, they will stop at 24th station. Now total stations are 325 divided by 24. So nearest value is 13. So they will together stop at 13 stations, right? Now first we checked for this, then this. Now we'll check for express train and bullet train. Now express train plus bullet train. Express train stops at 5th and bullet train stops at 8th station. So together they will stop at every 40th station. So this will be 325 divided by 40. So this comes out to be 8. So at 8 stations these 2 trains will stop. Now all these 3 trains, express train, bullet train and local train, stops at 3, 5, 8. So that is 8, 5, 40, 120th station. At every 120th station these 3 trains will stop. So that is 325 divided by 120. So this is equal to 2. Now we need to find the stations where exactly these 2 different types of trains will stop. So that will be equal to, when I subtract, out of 21 I will subtract 2, fine. Out of 13 I will subtract 2, out of 8 I will subtract 2. So the total will be 21 minus 2 plus 13 minus 2 plus 8 minus 2. Now 21 plus 13 is 34 and 34 plus this is 42. 42 minus 6. So this is equal to 36 stations where exactly 2 different types of trains will stop. So the right option is option number C. A number P is such that it is divisible by 7 but not by 2. Another number Q is divisible by 6 but not by 5. Then the following expression, which necessarily be an integer, is. So assume some values for this. Let us suppose for P we need to find a value which is such that it is divisible by 7 but not by 2. So minimum value I can take P is 7, right? It is divisible by 7 but not by 2. For Q, it must be divisible by 6 but not by 5. So minimum value I can take for q is 6. Now I need to find out of these options which will be necessarily an integer. Now taking the first option, so that is 7p plus 6q divided by 42. So this will be 7 into 7 plus 6 into 6, 36 divided by 42. So this is equal to 49 plus 36 divided by 42. So this will be equal to 5, 9, 6, 15, 437 divided by 42. So this will leave me a remainder 1. So this is necessarily not being integer. Now moving to option B. Option B is 5p plus 6q divided by 71. So 5p is 35 plus 6q is 36 divided by 71. So this will yield me 71 divided by 71. So this is necessarily a remainder 0. Fine. Now moving to option C. Option C is 6p plus 7q divided by 42. So this is basically 6 into 7, 6 into 7, 42 plus 7 into 6, 42 divided by 42. So that is 84 divided by 42. So remainder is 0. So I'm getting two options for this. Now we'll check for some other value also. Right. Now if I take p equal to 14, then it is divisible by 2 also. So I will take next value 21. Now for q I can take value 12. Right. Now I'll check for these two options. First is 5 into 21 plus 6 into 12 divided by 71. So this is equal to 105 plus 72 divided by 71. So this is equal to 177 divided by 71. So this is not an integer. When it is divided, it will give me answer in decimals. Now 6 into 21, option C, 7 into 12 divided by 42. So 21 into 6 will give me 126 plus 12 into 7 will give me 84 divided by 42. So 84 plus 126 is 210 divided by 42. So this gives me an integral value. So in both the cases you can see option C is giving me an integer value. So option C is the right option. The area of a paper can be divided into 144 squares. But if the dimensions of each square were reduced by 2 cm each, then the number of squares so formed are 400. The area of the paper initially was. Now, the area of paper can be divided into 144 squares. So let us suppose x be the side of that square. Side of that square. Fine. Now, the total area of the paper becomes, because it can be broken into 144 squares, so total area can be represented as 144 into x square. Right? Now, the question says that now the dimensions of each square were reduced by 2 cm each. Then the number of squares so formed are 400. So that means when the side is decreased by x minus 2, number of squares found are 400. So that basically means x minus 2 whole square multiplied by 400. Now according to the question, these two areas must be equal. So that means 144 x square should be equal to 400 x minus 2 whole square. Right? Now if I divide, so this will be 9 and here it will be 25. Right? Dividing by 16. So 9x square is equal to 25x minus 2 whole square. Right? Or I can write this as 9x square equal to 25x square plus 4 minus 4x. This can be represented as 25x square plus 100 minus 100x. This side 9x square. So this is basically equal to 16x square plus 100 minus 100x equal to 0. Or it is equal to 16x square minus 100x representing in standard form. Right? Now for this I need the product to be equal to 1600 and sum to be equal to minus 100, splitting the middle term method. Right? Now, so I can write this as 16x square minus 20x minus 80x plus 100 equal to 0. Now if I will take 4x common, I would be left with 4x minus 5, and here I will take common 8. No, 8 can't be taken common. If I take 20 common, so I will be left with 4x minus 5 minus 80x plus 100. Now 4x minus 5 as common, I would be left with 4x minus 20. So either 4x is equal to 5 or 4x is equal to 20. So x is equal to 5 by 4 or 5. So now this value I can't take, so integral form x is equal to 5. Now the area of the paper initially was, so area of the paper can be calculated either from this or from this. So 144 into x square 25. So 144 multiplied by 25 is equal to 3600 centimeter square. You can find area from this also. This would also be same. So the right option is option number C. Right? Thank you for today's lecture. Bye bye. Take care.